Hello again. Thanks for coming back. What we're going to do in this video is solve the system 2x minus 3y equals 2, along with negative 4x plus 6y equals negative 4, using Gaussian elimination once again. So remember, Gaussian elimination requires us to write this in matrix form. So this is 2, negative 3, augment 2, negative 4, 6, augment negative 4. And remember, the goal for Gaussian elimination is to get the matrix in this form, if possible. 1's on the main diagonal, 0 in the lower left-hand corner, and then the other 3 could end up being any number. It just depends on the row operations and what numbers come up there. So, all related to the problem that we're solving. So, if you watched the last video, we had the same coefficients, except for one of them is different. We want to get that 1 in the upper left-hand corner, and again, I don't have an equation to swap it with, so I'm going to take the first row, and I'm going to multiply it by 1/2, and just replace that. So the new row 1 is just the old row 1 multiplied by 1/2 on both sides. So that's going to be 1, negative 3/2, augment 1, negative 4, 6, negative 4. Okay, so now we're ready to do the big row operation. We want to get the 0 here, which means I'm going to use the first row. I'm going to multiply the first row by something, and the fact that there's a 1 there makes it easy to decide what to multiply by. If I want to get rid of a negative 4, I have to multiply by 4. So 4 row 1 plus row 2, and I'm going to replace row 2 with that, because again, I have row 1 exactly the way I want it. I have that 1 there. That's a big thing. So 4 row 1 is 4, negative 6 with an augment, and then 4. And then row 2 is negative 4, 6, and negative 4. This is interesting. So that means I have zeros on the left and zeros on the right. Well, that's my new row 2. So I'm now going to write the augmented matrix with the new row 2, which is just a bunch of zeros. So now what does this mean? A row of all zeros. In the last video, we saw zeros on the left with a non-zero on the right meant no solution. Now let's translate this back into equations. This is x minus 3/2 y equals 1, and 0 equals 0. Well, 0 equals 0 is always true regardless. So that means that these two equations in our system have boiled down to this one equation that has an x and a y in it. That means that this system has infinite solutions that are along the line defined by x minus 3/2 y equals 1. So how do we write the solution when that happens? Well, I'm going to take this equation, x minus 3/2 y equals 1, and I'm going to solve it for x. So what that means is the following. So given a y coordinate, given a value of y, the x coordinate is 1 plus 3/2 y, which is kind of backwards from how you're used to doing this. Usually the input variable is x and the output is y. Here we're saying given a value of y, the x coordinate is 1 plus 3/2 y, or the value of x is 1 plus 3/2 y, and that generates infinite solutions. If you let y equal 0, there's a solution that corresponds to that. If you let y equals 2, there's a solution that corresponds to that. Anything along that line is a solution to the system. And again, if you revert back to the graphing method, if you were to graph both equations in this system, you would notice that they produce the same line, which means all the solutions to that system are along that line. So that is infinite solutions using Gaussian method.